Hi students, it's Mr. Leg here. I've just got a quick screencast for you on area of kites, rhombuses and trapeziums. But now before we start, I want you to grab your notes and I'm going to be annotating a version of the notes here in front of you. I want you to grab your notes so you have them with you to take some notes as we go. Unfortunately, I haven't got the page numbers here, but if you turn to area of kites, rhombuses and trapeziums and maybe just pause me until you've found that page, have your pen ready to take some notes and away we go. All right, so today we're going to learn the formula for the area of rhombuses, kites and trapeziums. Don't worry if you're not absolutely familiar with those. We're going to tell you what those are in a second. And as well as learning the formula, I'm going to take you through how you actually develop the formula for kites, rhombuses and trapeziums. Because if you know how you develop the formula, then hopefully it'll be a little bit easier to remember. All right, let's get started. So let's use what we know about the area of basic shapes to develop some formulas. This first one is called a rhombus, and he is diamond-shaped. Now, you know how with rectangles we say length times width, and with parallelograms and triangles we say base and height as the dimensions by which you measure them. For rhombuses and kites, we use X and Y, sort of like X and Y standing for the length and the width of your rhombus. All right, so I want to just explain show you a couple of things by extending this diagram. All right, and then zooming in. So I hope you can see there that within, the rhombus is sitting within a red dashed rectangle. And the red rectangle has the same dimensions as the rhombus, X times Y. So let's zoom in on this top left corner. So I'm going to colour in the part of the top left-hand corner that is the rhombus. So within this smaller rectangle, I've got a quarter of a rhombus. And have a guess how much of that rectangle is the rhombus and how much is the empty space. Well, it seems to me that we have divided this rhombus exactly in half, corner to corner. So what you've got in there is a half of the little rectangle. And the same thing here. This one here is a half of that right-hand rectangle. And this one here is a half of the bottom left-hand rectangle. And this one here is a half of the bottom right-hand rectangle. So the area of the rhombus is just going to be a half of the whole rectangle, which would be X times Y. So the area of a rhombus is a half X times Y, where X and Y are these dimensions. So you can think of them as the length and width, if you like. X times Y. Let's have a look at a kite. And what you're going to find is that a kite is actually really similar. The formula is really similar. Have a look at that. We've got another big rectangle and we've got some smaller rectangles here. So let's have a look again at the top left-hand rectangle. How much of that rectangle is in the kite and how much is outside the kite? I think you'll be able to see that it's a half. And here again, how much is inside the kite and how much is outside? It's a half, and a half. So if the dimensions of the kite are X and Y, which they are, that's how we describe the dimensions of the kite, then the area of the kite is going to be a half X, Y, just like it was for a rhombus. So the area of a kite is the same as the area of a rhombus, which is a half X, Y. All right, let's have a look at a trapezium. All right, so the first thing we're going to do is label these sides. And what we call the two parallel sides, the length of each of the two parallel sides, we call them A and B. And the distance between the two parallel sides of the trapezium we call H for its height. Now, one of the things that I reckon is really cool about this is that what you've got here in a trapezium is actually just two triangles. It's two triangles. It's triangle number 1 and triangle number 2. And how do we work out the area of a triangle? We go area of a triangle equals, I better make it, hang on, I might draw a triangle there. I'll go area of a triangle is just a half base times height. So if we can work out the area of each of these triangles, and then we can add those together, hopefully we're going to get to the area of a trapezium. So the area of triangle 1 is a half. Now what's his base? His base is A. And his height is H. So area of triangle 1 is a half AH. Area of triangle 2. Let's have a look at triangle 2. Well, his base is B. So his area is going to be a half B times H. So the area of the trapezium is the two triangles added together is going to be a half AH plus a half BH. And so what we can do there is do a bit of algebra and say that equals H on 2 times A plus B. And all I've done there is to take out the common factors of a half and H and take them out the front. H on 2, A plus B. Don't worry too much if you didn't understand that last step, because all you're going to need to do, girls, is use the formula properly. But I thought it might be interesting to see how it's derived. But don't worry too much if that was a stretch. All right, so let's summarize what we've just learned. So the area of a rhombus is a half xy. The area of a kite is a half xy. And the area of a trapezium is the height of the trapezium, which is the distance between the two parallel sides, times A plus B, which is the two sides added together. All right, now just bear in mind that you will have a cheat sheet in the test, so you'll be able to have these formulas available to you in the test. All right, so let's use that information now to solve for the area of some fancy shapes, some examples. All right, find the area of these special quadrilaterals. First, state the name of the shape. All right, I reckon this one here is a kite. And I reckon that the area of a kite, I'll just check up here, what was it again? That's right, it was a half xy. What's x and y in this situation? Well, it actually doesn't matter which one we use, which one for each. I'm going to use 1 as y and 1.8 as x. So let's substitute our values in. A half times 1.8 times 1, which is, and you'll also have your calculator in the test too. So if you need to use it to do a problem like this, that's completely fine. And that is 0.9 millimeters squared, because we measure area in squares. All right, what sort of shape do you reckon this one is, girls? I reckon it is a trapezium. That's correct. It's a trapezium. What is the formula for the area of a trapezium? It is H on 2 times A plus B. Now, what were those things again? Oh, that's right. H is the distance between the two parallel sides, and A was one of the sides, and B was the other side. All right, so I can just substitute those values, and I should be able to calculate an answer. Equals 16 on 2 times 20 plus 50. 16 on 2 times 20 plus 50, which is 8 times 70. Well, I know 8 times 7 is 56, so 8 times 70 must be 560 millimeters squared, because we measure area in squares. All right, so here's a couple for you to try, girls, by yourselves. Have a go. Pause the video now and we'll see how you went. All right, how did you go? I hope that what you did is identify this first one as a kite and this second one as a trapezium. And we know that the formula for the area of a kite is a half xy, and we know we're going to call that one x and y. And note that it doesn't matter which way round you go, because multiplication is commutative. 4 times 5 equals 5 times 4. So let's substitute those values. X is 30 times 20, which equals, get your calculator out, I reckon that equals 300 millimeters squared. I hope you got that one right. And if you didn't, I hope you worked out what you could have done differently. All right, let's try this trapezium. Area of a trapezium equals height on 2 into A plus B. I'm going to call this one A, I'm going to call this one B, and this one, which is the distance between the two parallel sides, is the height of the trapezium, equals 5 on 2 times 4 plus 9 equals 5 on 2 times 13. I reckon that is 6.5 times 5, which is 32.5 meters squared, because we measure area in squares. All right, so that was a quick one. So have a go at the practice exercises for chapter 4D. The exercises that you should tackle are on page 3 of this booklet. And if you have any problems, don't be afraid to email me or your new teacher and ask questions. Otherwise, good luck with it. Thanks, guys.